lesson 23, inequalities with variables on both sides. In other words, with variables on both expressions. So very similar, we did something like this with equations. So here's our criteria for success. We want to recognize when we have opportunities to distribute, when we can combine like terms so we can simplify our expressions, and then we're going to use our inverse operations to move the variables to the same expression, as well as the constants to the other expressions. And we're going to make that movement happen. So we'll make some decisions, and then we're going to accurately calculate the solution using our inverse operations. All right, and isolating the variable. All right, we're going to start this first example. I'm going to rewrite it, and I am going to use our calculator on the side. And we get to make some decisions. I like to start with my variables first. So do I want to move this variable over? And that would mean subtracting. Would that make more sense? Or do I want to move this one over? And that means subtracting 1.04. So I noticed that if I were to subtract 1.04, I'm going to end up with a negative with the x. And that's not what I want right now. So I'm going to choose to start the other way. And I'm going to subtract this term, 1.02x. Now notice there was nothing for me to distribute, so this is the easiest place for me to start. And I have 3600 is less than 2000 plus, and when I subtract this, I have 0.02x. All right, so I also want to move all my constant numbers over to the other side. So I'm subtracting 2000 from both sides to create a zero pair. And I have 1600 is less than 0.02x. All right, and my last step is I'm going to divide by 0.02. So I know this is just going to be x on one side, and I'm going to use my calculator to ensure that I don't make a silly mistake dividing, and I get 80,000. All right, so here's my answer. 80,000 is less than x. Let's graph it and check. So here's 80,000 on my number line, and I want x to be larger. It's a larger number, so it's going to be to the right. So again, I'm going to draw my circle, leave it open, and I'm going to move. I want all the values to the right of 80,000. So everything bigger. Let's choose an easy number. I'm actually just going to choose, for our check, why don't we just choose 100,000? You might be saying, I thought you wanted an easy number. Yeah, I did. All right, so 3,600 plus 1.02 times 100,000. So let's do that math. 1.02 times 100,000, and I get 102,000. So 3,600 plus 102,000 is equal to 2,000 plus, and I'm going to do the same thing on the other side, 1.04 times 100K. And that's just going to give me, let me just move this down. God, these are big numbers. This is just going to be 104,000. Okay, now one thing that I'm noticing that I just want to correct, I was using equal signs because I wanted x to be equal to 100,000, and I started writing an equal sign here. So let's fix that. We know this is less than. Okay, so let's add on the other side. We have 102,000 plus 3,600, so that's 105,600 is less than 106,000. And this is a true statement. So we are done. So the numbers were a little long, so I definitely used a lot of space, but I did want to make sure that I was checking my values carefully. But we did it. Here we go. This was an actual Regents question, so hit pause and jot this down into your notes, and we have one more to try out together. All right, so looking at our next problem, I could already see we're going to distribute on both sides. So let's start there. So I have 4y minus 12 is less than or equal to 8y plus 4. So again, make a decision. Would you rather do minus 4 to move this one over or minus 8 to move this over? I would rather do the minus 4y. And now I have negative 12 is less than or equal to 4y plus 4. All right, let's move our whole numbers over. So I'm going to add the opposite. So here's our 0 pair. And now I have negative 16 is less than or equal to 4y. Divide both sides by 4. And my final answer is negative 4 is less than or equal to y. Let's test it. Here's negative 4. I want y to be greater, so it's all the numbers here on this end. Fill in the circle because it can be equal to. And I want all the values that are greater than negative 4. All right, so let's test this. I'm going to choose a number that is greater than negative 4. I'm going to choose 0 when y equals 0. So 4 times 0 minus 3 is less than or equal to 4 times 2 times 0 plus 1. All right, so 4 times negative 3, which I know is going to be negative 12, is greater than or equal to 4 times 0 plus 1 is just 1. So I end up with just 4 on this side. Is negative 12 less than 4? Yes, it is. So we are correct. All right, and I chose 0 for that reason because I knew I was going to have to multiply with zeros, and that would probably make it a little easier for me down the line. All right, so let's look at our criteria for success. Did I recognize when to distribute? Absolutely. I could see it right away. Did I combine any like terms? Well, in this case, I didn't really have any like terms to do. I did use my inverse operations to move. I made a decision. I decided to move this term over here to this side. And I also accurately found my solution and isolated my variable, and I went further and checked my work. That's it for today's lesson, Math Marbles. Even though our inequalities are more sophisticated, we are still using the same mathematics from equations to solve these multi-step inequalities. I will see you in the next lesson. That was a big firecracker. I'll see you in the next lesson, Math Marbles. Be well.